Good afternoon, Keys Precalculus. We are going to work a few more examples in section 4.3 on this video and a couple of application problems, and hopefully this will help you with the rest of your homework. Before we get started, I want you to see that on the screen I put up here from your book the fundamental trig identities that we have learned so far: the reciprocal identity, the quotient identities, and the Pythagorean identities. I also included the cofunction relationships in the bottom right corner of that. So that's what we're going to be using to solve these problems, not your unit circle information. You can use your unit circle information to do this. However, the whole idea is to practice using these identities, because there's often more than one way to solve a problem, and sometimes some ways are easier than others. And so the whole point of this is to practice using your trig identities. So I'd like you to look in your book on page 275 at number 28. You're given the sine of 30 degrees is 1/2, which you should already know that, and the tangent of 30 degrees is the square root of 3 over 3. And that's another one you need to be working on memorizing. But they want you to find from that information, they want you to use your identities that we've learned so far to find the cosecant of 30 degrees, the cotangent of 60 degrees, the cosine of 30 degrees, and the cotangent of 30 degrees. So instead of drawing a triangle and finding your trig functions that way, we are going to use the trig identities instead. I would like for you to pause the video and try to work through these 4 problems by yourself, and then turn it back on, come back, and we'll work through them together. Okay, let's look at part A. It says to find the cosecant of 30 degrees. Now, which of these identities could we use for that? Well, we look up here at the reciprocal identity. We see that sine is related to cosecant because they're reciprocals of each other. Or cosecant is the reciprocal of sine. So we could say that because the sine of 30 degrees is 1/2, we know that the cosecant of 30 degrees would be equal to 1 over the sine of 30. Sorry about that, I needed to write that. The sine of 30 degrees. Oh my goodness, 30 degrees. There we go. I got that from this relationship right here. Okay, and I know that the sine of 30 degrees, I was given 1/2, which we should memorize that anyway, and the reciprocal of 1/2 is 2. So we know that the cosecant of 30 degrees is 2. Now let's look at the next one. It says to find the cotangent of 60 degrees. Now, tangent, we were given tangent of 30 degrees, and tangent and cotangent are reciprocals of each other. However, one is finding the tangent of 30 degrees, and one is finding the cotangent of 60 degrees. So we can't use the reciprocal identity. But look at 30 and 60. What do you notice about those? Those two numbers add to be 90. 30 and 60 are complementary numbers. And we can see over here by the complementary relationships that tangent and cotangent are cofunctions of each other. And even more specifically, the cotangent of 90 minus theta is equivalent to the tangent of theta. And because we're looking for the cotangent of theta, and we have the tangent of theta, that's the one we're going to use. So the way we use this is we say the cotangent of 90 minus theta. And this is the theta we're given, so this is the theta we're going to use. We know that this cotangent of 90 minus theta is equivalent to the tangent of that theta. So when we fill in our numbers, we've got the cotangent of 90 minus 30 is equal to the tangent of 30. Well, the cotangent of 90 minus 30 is the cotangent of 60, and that's what we're looking for. And we're given that the tangent of 30 is the square root of 3 over 3. So we can now know that the cotangent of 60 is the square root of 3 over 3. Now let's look at part C. there's a number of ways we could approach this. We know the sine of 30 degrees. We know the tangent of 30 degrees. They want us to find the cosine, of 30 degrees. We could use the Pythagorean identity of sine and cosine, but looking at 1/2, we see that that's not going to be an easy thing to take the square root of. So, I mean, we could do it, but I'd rather not. There's another way we can approach it in this case, and that's if we look at the tangent of 30 degrees. How do tangent and cosine relate to each other? Well, we can see over here that they're related here in the quotient identities. The tangent of theta is equivalent to sine of theta divided by cosine of theta. So that means that the cosine of theta is equal to the sine of theta divided by the tangent of theta. And you find that just by going through simple algebra steps. So we know, basically this is saying that the cosine, I should have said we know, sorry about that. The cosine of 30 degrees is equivalent to the sine of 30 degrees over the tangent of 30 degrees. We know the sine of 30 degrees and the tangent of 30 degrees. We're looking for the cosine of 30 degrees. So the sine of 30 degrees, they tell us, is 1/2 divided by the tangent of 30 degrees, which is the square root of 3 over 3. So that's the same thing as saying 1/2 times 3 over the square root of 3. Okay, so when we multiply that out, we get 3 over 2 square roots of 3. And when we simplify that by rationalizing the denominator, we get the square root of 3 over 2. Now that's one of the, actually all of these are the functions that you need to memorize, but the point of this exercise again is just to walk through using the identities. You can see this one straight on your unit circle. It's something that you need to start committing to memory, but again, I know I keep saying it over and over again, we're walking through learning how to use the identities. And this last one, finding the cotangent of 30 degrees, which identity do you think we're going to use for this? We could use a number of them. We could use this quotient identity and say the cotangent is cosine of 30 divided by sine of 30, because we know both of those. We could also, more simply, use the reciprocal identity that cotangent is equivalent to 1 over tangent. So I'm going to write cotangent of 30 equals 1 over the tangent of 30. And when I substitute that in, I'm going to say 1 over the square root of 3 over 3. And when we simplify that down, we're just going to see that it is the square root of 3. I'm not going to walk you through that. You're rationalizing the denominator. You can do that on your own. All right? So let's move on to the next problem. Okay, I want you to try page 275, number 32 on your own. I'm not going to walk you through them. I'm going to put the answers up here and show my work. So what I want you to do is pause the video, work through the problem, and then come back and check your answer with what I have. You're given the tan of beta is 5. Find the cotangent of beta, the cosine of beta, the tangent of 90 minus beta, and the cosecant of beta. And let me just give you a little hint. Part B is going to use 2 identities, and it's a little more involved than what you've been used to doing. But push through and try it. I think you can do it, and I think you'll do fine. All right, here are the answers. I want you to go ahead and pause the video again and see if you can figure out what I've written down here. I've tried to color code it. So part A I did in green, and I boxed the identity I used. Part B, orange. Part C, blue. And part D, kind of a fuchsia color, I guess. Purpley, magenta, more color. Anyway, I don't know what it is. Anyway, I'm not sure what it shows up on your screen either, but that doesn't matter. Part B uses the Pythagorean identity of tangent, and that relates tangent and secant, and then it goes back and uses the reciprocal identity because secant is the reciprocal of cosine, and that was the only way we could get to cosine from tangent. We had to go through secant first. And then part D also uses the Pythagorean identity. So go ahead and pause it, look over it for a few minutes, make sure you understand it. If you don't, we'll go over it in class next time. All right, I'd like you to look at page 275, numbers 34 and 38. These are very similar to the ones we already worked together in class, so I want you to pause the video and I want you to try to solve these on your own. And the idea is to transform one side of this equation, of each equation, into the other side of the equation. And you can work with either side of the equation that you want, but because the left side on these is more complicated than the right side, it's going to be beneficial for you to work with the left side and see if you can transform it into the right side. Because, you know, one can be transformed into anything, and that's not going to help you. So I'm talking about number 38 here, the purple one. So go ahead and work on these, and then come back and check your answers. All right, let's go ahead and work through number 34 together. We've got cosecant theta times tan theta, and we want to turn that into secant theta. So if we look at all our identities and our cofunctions, do we see how cosecant, tangent, and secant relate to each other? Well, none of them are directly related. Cosecant and tangent are not directly related. Secant and tangent squared are related by the Pythagorean identities, but we've got cosecant in there, so that's not going to help us. So we're going to have to do something else. We're going to have to go about this in a little bit of a roundabout way. Can cosecant be transformed into something that relates to tangent, or can both cosecant and tangent both be changed into something that relate to each other? Yes, they can. Over here, I've got cosecant theta is the reciprocal of sine theta. So cosecant theta is equivalent to 1 over sine theta. And then I've got tangent theta is equivalent to sine theta over cosine theta. So let's go ahead and start with these two relationships and see where it takes us. Okay, I can rewrite cosecant theta as 1 over sine theta because of the reciprocal identity. I can rewrite tangent theta as sine theta over cosine theta because of the quotient identity. Now, here I've got 1 over sine times sine over cosine. Because this is on the denominator and this is on the numerator and they're multiplied, they cancel each other out, and I'm left with simply 1 over the cosine of theta. Now, that doesn't give me secant theta yet, but if I come over here and look at my reciprocal identity, I do see, in fact, that 1 over cosine theta is equivalent to secant theta. So this here is equivalent to secant theta. Therefore, I have transformed the left side into the right side. See how that works? Now, I'm just going to put the answer up here for 275, number 38, and let you check it because it's almost exactly like what we did in class today. Okay, we used the Pythagorean identity here. Well, first of all, I multiplied cosecant plus cotangent times cosecant minus cotangent. It's similar to a difference of two squares, and when we FOIL it, we get, you remember, a plus b times a minus b is equivalent to a squared minus b squared. So that's what we did here. And when we got cosecant squared minus cotangent squared equals 1, we see that that is just a derivation of the 1 plus cotangent squared equals cosecant squared. And if I wanted to put them both on the same side, I would subtract cotangent squared from both sides and be left with 1. So I get 1 equals 1. And it works out simply. All of these problems that we've just done should help you with your homework, except for the application problems. So we need to go through a few of those as well. Before we do our examples, I want to talk about a couple of different kinds of angles. Angle of elevation and angle of depression. Okay, so the green one here, I've got green for the ground, green grass or whatever. The green one here shows an eyeball looking from the horizontal, looking up. So an angle of elevation is represents an angle from the horizontal upward towards an object. It's how far you have to look up or how far you have to raise something to reach from the horizontal to that object. Angle of depression is the opposite. It's how far you're looking down from the horizontal to reach an object. It represents an angle from the horizontal downward towards the object. So this blue angle, I'm thinking of the sky looking down, or the water looking down to the bottom like a submarine or whatever, is the angle of depression. This green one is the angle of elevation. I hope my kooky little examples help you remember that. So let's go ahead and look on page 272 at example 7. It says, a surveyor is standing 50 feet from the base of a large tree as shown in figure 4.29. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? This is a realistic problem that surveyors actually have to solve. And so we're going to practice doing that here. Okay, so I've drawn a little picture similar to what's in your book. It tells us that the surveyor, the little person, which I forgot to draw him, he's standing here at 50 feet away from a tree. And we know that his eyeballs have to look up, or from ground level, he has to go up. Not from his eyeball level, but from his ground level. He goes up 71.5 degrees to look at the top of the tree, or for his instrument will go up that high to the top of the tree. And we want to know how tall the top of the tree is. So I've labeled, because this is a triangle, I've labeled this as X and Y. Now, it's not really in the standard form, because this would be in the negative direction if we were putting it on a coordinate plane, but it really doesn't matter. X is the horizontal, Y is the vertical. X we know, we want to know what Y is. And we can look at this as a right triangle. This could be our little right angle right here. So what trigonometric relationship do you know that compares an angle to a leg and another leg? Well, looking at this angle, we are given the adjacent side. We're looking for the opposite side. So which trig relationship uses opposite and adjacent? You're right, it's the tangent. Tangent of theta, in this case our theta, is 71.5 degrees. So the tangent of theta is equal to the opposite over adjacent, or the y over the x in this case. Or you can think of it as opposite over adjacent, however you want to think of it. Now we don't know what the y is, but we do know what the x is. So let's go ahead and see if we can solve this. So I'm going to write tangent of 71.5 degrees equals y over 50 feet. Now, I want to solve for y, so that means I'm going to multiply both sides by 50 feet. So I've got 50 times the tangent of 71.5, which you can solve simply on your calculator by hitting tan and then 71.5 and then enter. But make sure that your calculator is in degree mode and not radian mode. Otherwise, you're going to get a different answer. And when you multiply that out, you're going to get approximately 2.9886, okay, equals y. And so then when you multiply those two numbers together, 50 times 2.9886, or 987, I guess if you round up, that's probably more accurate to say 7 there, then you're going to get the answer of approximately 149.4 feet. And that's your y. You've solved for the height of the tree by using a trig function, the trig function of tangent. Okay, let's look at example 8. It says you are 200 yards from a river. So I've drawn your river up here. Rather than walking directly to the river, straight up, which is 200 yards from that would give you your right angle, you decide to walk 400 yards along a straight path to the river's edge, because you want to be in a different spot, you want to follow the path, maybe there's, something in the way from those 200 yards. So you're going to walk 400 yards. So it says, find the acute angle between this path and the river's edge as illustrated in figure 4.3, which I sketched something similar to that here. So let's look and see what we have. We have a right triangle here. And in this right triangle, we can call this X if we want. We can call it Y, we can call it whatever. And we can call this radius, or we can also think of it as the hypotenuse or the radius, whichever we want to think of. So and then we have this angle up here. And I want to know, when I walk from where I am to the river, what angle is between this path that I walk and the river's edge. So I've got my theta right here. This, again, if you're thinking of a unit circle, this would be in the third quadrant, but we're not doing direction that way, so we're just going to use the numbers we have as a right triangle. So we've got a theta, we've got our angle theta, we've got our hypotenuse here, and then we've got the side that's opposite theta. So what trig relationship relates opposite and hypotenuse? Yes, sine. Sine theta relates the opposite over hypotenuse. Now in this case, our opposite we know, we call it whatever we want, but we don't need to call it a variable because we know it. It's 200 yards. Okay? And our hypotenuse is 400 yards. So this reduces to 1/2. It's going to be simpler to solve this if we reduce it to 1/2. And you should know by memory, hopefully, but if not, looking on your unit circle, that the sine of what angle is 1/2? The sine of 30 degrees is 1/2. So theta, in this case, would be 30 degrees. Now, it doesn't always work out this simply or this nicely, neatly, so you do have to know how to do this on your calculator. So the way that you can find this on your calculator is if you hit the blue button, the second button, and sine. That's going to give you the inverse sine, and then 0.5, enter, and that should give you 30. But only if you're in degrees. If you're in radians, it's going to give you a different answer. So make sure that you're in the degree mode when you're working with degrees, and radian mode when you're working with radian. Now, you need to go ahead and study example 9 on your own. Just read it in the book. It gives a good explanation. In fact, you should probably look at it, try to solve it on your own, then study it and see if you did it the right way. It's very self-explanatory when they, or not self-explanatory, they explain it well. So you can go ahead and try to practice working with that. And then once you've done with that, you're ready to start your homework. Y'all have a great weekend.